Hello, my dear friends. Today we are going to see about Linux process APIs. Before getting into the topic, let us see about myself. I am Hirtik Sudhakar and I am studying BTech Artificial Intelligence and Machine Learning degree at Savita Engineering College. Now let's see why are process APIs important. Linux process APIs play a vital role in facilitating the creation, control, and communication of processes within the Linux operating system. Empowering developers to build a robust and scalable applications, understanding these APIs is a fundamental for anyone working with the Linux-based systems and programming environment. Now let's get to know what are the process APIs. There are majorly three process APIs, which are for exec and wait APIs respectively. Now let's get to know more about these APIs. First, we'll start with the fork API. The fork system call is used to create a new process by duplicating the calling process. Upon successful execution, it creates a child process that is an exact copy of the parent process, including its memory, file descriptors, and execution content. The child process receives a unique process identifier, namely PID, and both parent and child process continue execution from the point of fork call. Fork returns different values to the parent and child processes, 0 to the child and the child's PID to the parent. Now let's get to know about exec family. Exec family of a system calls is called to execute a new program within a process. It replaces the current process image with a new one, loading the specified program into memory and beginning its execution. There are different variants of the exec call, namely execv, execcl, execv, etc., that provide flexibility in passing arguments to the new program and setting environmental variables. After a successful exec, the process retains its PID, but its memory space and execution context are replaced with those of new program. Now let's get to know about wait call. The wait system call is used by a parent process to wait for the termination of its child process. It suspends the parent process until one of its child process exits or terminates. Upon termination of a child process, wait returns the PID of a terminated child, allowing the parent to handle its exit status and perform cleanup tasks. Wait can be used in conjunction with other system calls like wait PID to specify which child process to wait for and to customize its behavior. Now let's get into the code, my dear friends. And yes, my dear friends, now we came here to a Linux terminal to check the fork check process and the exec check process. First of all, we'll be declaring the header files such as include stdio.h, include stdlite.h for input output operations and memory management, etc. In the main function, we'll be declaring a variable called PID, which will store the PID of the child process, which will be creating using the fork call. And we'll be checking for the PID to be 0. If the PID is 0, it will print that I'm a child and my PID is this by using the get PID command. And then we'll be printing the my parent PID using the get ppid function, and they'll be exiting using the exit command. If else this process fails, that is if fork doesn't happens, we'll be only printing the parent PID using the get PID function, and we'll be exiting using the exit command. And now let's execute the execcl function. In this function, in the main function we'll be declaring a variable called status, which will be used to store the exit status of the child process, and then we'll be printing a indicating that the ps command will be executing using execlp, and then executes the ps command using execl. This function replaces the current process with image of a new one, in this case running the ps command with the specified arguments ps ax and null. And the next line will be using the wait and status, where this waits for the child process to terminate and stores its exit status in the variable status. This ensures that the parent process waits for the child process to finish executing accordingly. And next line checks if the child process exited normally using the wife exited macro. If it did, it prints the exit status using a wife exit status. If not, it indicates that the child process did not execute successfully. And then it will print a message called done. And then we'll be printing a message that indicating that the ps command will be executed again, this time specifying its full path. Execcl commands executes the ps command using its full path. This ensures that the command is executed even if it is not in the current directory or included in the system's path environment variable. And then wait and status waits for the child process to terminate and stores its exit status into the variable status, and then checks if the child process exited normally and prints its exit status accordingly. Then it prints a done message accordingly, then exits the program with a status code of 0 indicating successful execution.
And my
That's
dear
all about the
friends, now
code,
we'll be
my dear
executing the
friends.
commands.
Now I'm going to first execute the forkcheck.c. I'll be using the dot slash command to execute the fork check. Before executing the fork check, we have to compile it using the GCC command. If I execute the program, my friend, it shows that I am a parent, my PID is 3410. I am a child, my PID is 3411, and my parent ID is 3410. It states that the program has successfully executed, that the fork has successfully happened. Now we have to check the execute command. And now here I'm going to execute the dot slash ec command, my friends. And this command prints that it executes the ps command with exit clp, and the child has exited successfully. And then it mentions that the ps command is executed using the exit clp with its own path. And now it lists the all and every process executing in my system, and that's how the program works, my dear friends. And yes, my dear friends, now we reached the end of our program. So thank you for watching my content. Please let me know if there is any doubt in the comment section. Thank you.